Okay, our presentation called Canon, based off our look of our Canon.
What we propose is ENGR and cross-launcher, and second one is rubber band provides main power for launch, and third one is multi-diameter tracing.
So like our general design for the barrel is so we had a seat for the ball, which is right here, that pulls back, and then we had two rubber bands connecting the seat. So we had these two, also connects to that, and we also have two sets of railings. So it's these two, and then one motor that pulls back the seat, and then the touch sensor, which when it gets pushed back, the ball falls into it and it shoots. And then so when the rubber band was getting pulled back, it was kind of bending these, so we reinforced it with extra rails on the side. And also we flipped the motor around just so we could have a longer barrel for longer shooting. And so the arm can get guidance, so we had these two small pegs attached to the side of this so they wouldn't go anywhere. And then we just added more rubber bands to kind of stabilize it.
So we had difficulty integrating the reloading chamber here on the side, or I mean on the top. And what we came up with was a ramp system here that just kind of like gravity feeds the balls in. There's also a peg back here that keeps the ball from coming back, because when this rail comes back, it actually pushes the ball up when you're having a problem where it's like pushing it back, and so then it wouldn't fall back into place. Then there's actually a spring in here. And basically what happens is that as this sled comes back, it comes in contact with this spring, and it's kind of like it pushes back and lets the ball drop into place, and then it'll push back forward to keep another ball from falling in.
So there's a picture on the slide.
Oh, yeah, right here. And then we added because it would sway back and forth. Every time it would come back in contact with the spring, we actually added this peg that's connected to the touch sensor, so it keeps it all in line. Some of the malfunctions we had was sometimes the ball would either not fall in or it was too loose up here. And one of the struggles we had early on is that it wouldn't fall in, but as the motor kept pulling it back, it would finally release, and it would either like fall off to the side or shoot incorrectly. Another issue was that sometimes it would come back and it would shoot prematurely, so the axle here would keep going back without touching the touch sensor to stop it. So it would just kind of tear this whole thing off. And like I said before, this would either sway back inside, so we had to add these long arms here to keep it in line. That way it wasn't coming off track and everything was staying straight, so it could actually feed properly.
The main component is the one gear for the turn table and one gear for incline wheel. And the main problem from these two gear, but the problem is with the last one here. This gear.
And our program, pretty basic actually. We used a touch sensor and a sound sensor. It starts out with motor B, which is the one very back connected to the two strings. So then we'll pull back the seat, and it'll keep going back until the seat comes in contact with the peg connected to the touch sensor. Once that activates, it'll stop. The program waits for us to make a sound, and it'll go back for a fraction of a second. So now it's up against the wall. So the two side arms right over here will just pop off, and this thing will release with the force of the rubber bands. Once that happens, it'll level again. That's the motor seat, and it'll rotate, which is the right bottom motor, kind of hard to see, and that repeats twice more. And some programming challenges, really not too many. Again, we didn't use two back sensors. We only used two main ones, and so not that many problems. We just had to readjust sometimes the power when it would incline incline level, it gets screwed up, and we have to fix that up. Also, when it rotates, we have to put the power on that. Sometimes it will only turn to like just a few degrees. And then also, when the two guide arms come off, we needed a right amount of time to actually bring them back for it to relaunch. This is actually like a ramp, so these will slide up and pop back in. So it's at about like 15 seconds right now.
So some of the design flaws we had, we initially wanted to keep use the ultrasound sensor down here to actually determine like how far a target was, and then have it like rotate to compensate for like firing distance. But unfortunately, we never got that far. We just kind of left it there because it looked cool. The inclination here actually needed to be limited because we were trying to find a good center of mass. This barrel up here is actually really heavy. You can kind of see where it's putting a little bit of tension on its back turntable. So we had to play with where it actually attached to these gears here. And when it would incline either too fast or too slow, sometimes it wouldn't even go, or it would just kind of like flop backwards and then not be able to like raise itself up. The weight and the weight distribution also made it hard for it to either rotate too, because it was putting all this tension back here, so it would put an offset on this side here, whereas over here it was more level. And then originally we had like those big black gears down here on the actual inclination motor here, and those black gears, they don't mesh very well, so because of all this weight distribution, it would be skipping gears. So we actually went with these like deeper toothed gears, which are like the gray ones, and it actually functioned a lot better and actually gave us a lot more stability.
So, and we got it working for the most part. Working is pretty nice, but our design, well, if we had more time, more pieces, we'd want to make a longer barrel. And also something that we could have done, I guess we just didn't have enough time for it, is actually add more rubber bands to have more force. There is the ultrasound connected to it. Maybe you guys are wondering. That has no use at all. We had it there before. We were planning on using it, but never got to it. We used nearly all our pieces, so that was a problem. You guys know this because we took a lot of your parts. Yeah, that's it.
Okay. Yep.